Yes, so recording will be start. Okay. Now I'm going to share my screen again. So this is my signal. Now there are two approaches. One is the forward approach and second is the backward approach. Okay. So what is the meaning of forward approach? Is that when I start with the forward side. Okay. So first thing is that it is multiply by two. So that means first operation that we have to perform is the scaling operation. And which type of scaling operation is it? Compression by 2. This is the first operation. And second operation that we have to perform is the minus 3 by 2. That means,
Shifted.
and shifting is what? Minus, that means signal should be delay with 3 by 2. Okay. Now if we go to the backward approach, so we start with this one. So first thing that we have to do is first shifting with uh, delay of 3. Delay of 3. This is the first operation. The second operation is that we have to scale the signal. And scaling is what? Compression by 2. Okay. Now we do that. First of all, we do the forward method. So we compress the signal. So after compression, what will be the signal? It's minus 1 becomes minus 1 by 2. Okay. 1 and 2 becomes 1. Okay. And 3 becomes 3 by 2. Okay. So this is x of 2t. Now we have to shift the signal by 3 by 2. And shift is delaying. Okay. And in the delay side, what we do? We just shift my signal into the right side. So my signal point will be added by 3 by 2. So if minus 1 by 2, it's if I add 3 by 2, so it becomes 1.
One.
Okay. 0 becomes 3 by 2. Then 1 becomes 5 by
5
2.
by 2.
And then 3 by 2 plus 3 by 2 becomes 6. Okay. This is my x of 2t minus 3. Now, similar way, if I go with the backward approach, so first is that we have to shift the signal. So now I am going to shift my signal. So the signal that is started from minus 1, it will be start from 2. Okay. The signal point that is at 0, it will be moved to the 3. Again, the signal at 2 points, it will becomes 5. Okay. And the signal that is at 3 point, it becomes 6. This is x of t minus 3. Now what I do? I have to compress this one by 2. So if I compress this one signal, so what will be happen? All particularly points will be divided by 2. So this 2 divided by the 2 is becomes 1. The 3 divided by 2 is 3 by 2. The 5 divided by 2 is 5 by 2, and 6 divided by 2 is, and that signal is x of 2t minus. So either I go with this or either I go with this, we get the same answer. Okay. Now, if I want to check, this is the way to particularly solve. Now, if I want to check,
Sir,
yeah,
sir, I have a question here.
yeah, wait a minute. I just
Okay.
now if I want to check the output is correct or not, it is a quick method. Okay. So what I do in this case that my signal I just take that this is my starting point and this is my ending point. Okay, for xt signal. Now for the yt signal, if I becomes 2t minus 3 should be start equal to the starting point. Okay, signal is 2t minus 3 and it becomes to the equal to the starting point. So for this one, if I get the value, so what is the value? The value of t is equal to minus 1 plus 3 divided by 2. That means it becomes 1. Okay, so now my starting point is 1. So if I draw the graph, my starting point will be 1. Okay, now if I check to the ending point, so 2t minus 3 becomes equal to 3. So t is equal to 3 plus 3 divided by 2, that means 3. So my ending point will be 3. So my signal should be lies between 1 to 3. So this is my starting point, this is my ending point. So my I draw the signal. Okay, this is a quick review that your answer is correct or not. Yes, any doubt?
Yes, sir.
Now, what is your doubt?
Sir,
What is
like
your
for
question?
example, if I have a
Mhm.
square wave,
Mhm.
which is from -2 to -3 to -2, the
Okay.
square signal. Okay,
That
and
is a simple square signal.
yeah, square pulse, and it is from -3 to -2. Only -3 to
Minus,
-2.
okay, minus 3 to minus
Yeah, and I want to scale it by 2.
2. Okay. Scale, time scaling or the amplitude scaling?
Yeah, amplitude will be same, just time scaling.
Okay. So if this the signal is like if it is a xt signal, so you have to draw yt signal that is equal to x of 2t.
Correct.
Okay. Now what I do? This is my starting point. I'm taking this is my starting point and this is my ending point.
Yeah, correct.
Okay. Now simple way here 2t is equal to minus 3 starting point. That means t becomes minus 3 times I. So this is my starting point. Second, if 2t equal to minus 2, that means t is equal to minus 1. This is my ending.
Okay.
Okay. Now draw the circuit signal.
So you are saying the signal will start from -1.5 and end at -1.
Yeah.
So, but sir, like -1.5 is okay, okay, yeah, correct.
It is not possible in discrete signal, but it is possible in the continuous signal. No?
Yeah, correct.
I think this is your doubt.
Yeah, correct, sir. Yes, sir. -1. Yeah. Thank you, sir.
Any other doubts? Okay. Now similar way, if I draw the signal, the signal should be any type. Like -3, -2, -1, 0, and 4. This is my x signal. Okay. I have to do x of t by 2 minus 1 by 4. Uh, this, I'm taking it as a 1. T by 2 minus 1. Okay. Now, can you tell me? Again, we are going with the two
Yes, sir.
approaches.
So like I
In
guess
the
the if first we do the shifting operation by -1 and then the scaling operation by 1 by 2, it will be easy.
that is, I just tell you two approaches. You can solve it any other method.
Yes, sir.
Okay. So if I go to with the forward approach, so x first is 1 by 2 factor I coming with respect to t. So I am taking 1 by 2 common. So it becomes t minus 2. Okay. And if I go to the backward approach, it is becomes t by 2 minus 1. Okay. Now, if we go with the forward approach, first is time scaling. And which type of scaling is that? It is expansion of by 2. Okay. Second factor is time shifting. How much shifting is that and which type of shifting is that?
Yes, sir. So like the in this forward approach,
Yeah, in the forward approach, time shifting and time shifting by it is a
2.
delay
Yeah.
by. Okay. Now if we go with the backward approach, so first is the time shifting, okay, and delay by 1. And second is time scaling expansion by 2. Okay. Now we start. So first of all, the time scale. So now my signal should be that signal that will be started from the -3. Now it will be started with -6. Then -2 becomes -4. Then -1 becomes -2. Then 0 becomes 0. And then 2 becomes 4. Okay. So this is the x of t by 2. Now shift this signal. Okay. So now I shift the signal by 2. So -6 becomes -4. minus 4 becomes minus 2, minus 2 becomes 0, 0 becomes 2, and 4 becomes 6. So this is x of t by 2 minus 1. Now we go to the backward. So first of all, we do the delay. So the delay will be this one. So the signal that is started from minus t becomes minus 2. The signal that is go from minus 1 becomes minus 2 becomes minus 1. The signal that is minus 1 that becomes 0. The signal that is 0 becomes 1, and the signal that is 2 becomes 3. So this is of x of t minus 1. Now we do the compression expansion. So now minus 2 becomes minus 4, minus 1 becomes minus 2, 0 becomes 0, 1 becomes 2, and 3 becomes 6. X of t by 2 minus 1. Both are same. Okay.
Yes, sir.
Now, in a similar way, the reversal is also done in the week 1 or week 2 time reversal.
No, sir. In week one, it's just shifting and scaling.
Okay. So if we go with the week 2 part, if you have no doubt with this, we go to the week part. Week in the week part we add the time reversal also. Okay. So ft signal is given. We have to calculate the yt signal. The value of yt signal is x of minus 3 by 2t minus 1 by 2. Okay. Now we are taking the reversal. Basically, first of all, what is the reversal property? Like if I have a xt signal, okay, xt, it will start from minus 2, minus 1, 0, and 1. Okay, like this one is the my xt signal, or we can say that. So reversal property, what do it basically take a mirror image. Okay, like if you are seeing in a mirror, so your right hand will be like a left hand and your left hand will be right like a right hand. So similarly the reversal property is nothing but a mirror image, and mirror image with respect to this mirror. Okay, so the response is just a mirror image. Like if we say that right side of this particular behavior is like that, it will be start from 2 and it will be go to the higher value at t is equal to 0. So now if I take a reverse mirror image, so it becomes start with the minus 2, go with the higher point at t is equal to 0. Okay, now we go to the negative side. Again, from this t is equal to 0, it will be reducing at t is equal to -1. So now from t is equal to 0, it will be reducing at t is equal to 1. Okay, and from 1 to 2, it will be behaving as a step signal. So 1 to 2, it will be behaving as a step signal. So we can say this is the x of minus t signal. Okay, so this is about a reversal property, time reversal. Now we are using this property here in my signal xt. So like for example, I am taking, this is my xt signal. Okay, and I am using the time reversal property. So x of minus 3 by 2 t minus 1 by 2. Now forward and backward approach is we have to use here. Okay, and in this particular technique, either you can use forward or you can use backward. Just remember one thing, that is it, are you doing that if you are taking the minus sign, so you are taking the minus sign from the all, or like, because we have three operation now, time shifting, okay, time scaling, and time reversal. We have three particularly options. So the order of these options is very important. Now for the two operations, it is not very too much important, but for when we are talking about the three different operations, time scaling, shifting, and reversal, and all three are applicable for this signal. Okay, so in this scenario, we have to particularly define that which particularly order we have chosen. Why? Because if we are initially doing the reversal, then after I do the scaling, sorry, shifting operation, and after that I do the scaling option, your answer will be incorrect. Okay. Any doubts? Yes. Any doubts?
No doubts.
No, sir.
So for identify that which operation we have to perform first and which operation we have to perform second, the forward as well as the backward approach is very important. Okay, so what I do, I just take a any of the approach you can use. I am just using solving with the both approaches, the forward and back. Okay, so in the forward, when I go to from this side, so minus 3 by 2 is common. What will be remaining part? T, this minus I have already taken, 1 by 2 I have already taken, so it becomes 1 by 3. Okay, if I go to the backward part, the signal is same, minus 3 by 2 minus 1 by 2. Okay, now in the forward path, first step is that this minus sign, time reversal, then time scaling by 3 by 2 factor, and this 3 by 2 factor basically compress the signal. Okay, and then time shifting is 1 by 3, and this 1 by 3 is advance. Any doubt? Now if I go to the backward approach, so the backward approach is that first we have to shift the signal. That is delay and with 1/2. Then we have to scale the signal. Compress 3/2. And then we have to reverse the signal. Okay, so if you see that in the forward and backward, the approach is different. In the forward approach, forward method, if we are doing the signal by advance but by 1/3, in the backward method it is becomes delay by 1/2. Okay, so complete thing is different. So these two methods is only important to identify what steps we are following. Either we are going with the backward or either we are going with the forward. Now draw the signal according to these three steps, and you can check that answer is correct or not. Okay. After that, verify that through the quick method that we discussed in the first question. This quick method. Okay. The starting point and ending point, and check with the time signal. So you can check your answer is correct. Any doubts? Yes, any doubts?
No, sir.
Okay. Now, if you have any question, you can ask any particular signal or any particular questions. That is not a part of your assignment. Remember this. That is not a part of your assignment. Okay, so you can ask me the questions. Okay. Any questions with respect to scaling, shifting, and reversal? No doubts? No doubt?
No doubt.
Okay. You want to ask any topic that we discussed, you can tell. So have you discussed the step signal? or impulse signal? Yes. Have you studied this?
Yes, sir.
So can you tell me what is the step signal and what is the impulse signals? Yes, tell me what is the mathematical equation of step signal, ramp signal, impulse signal?
So
What
U
are
of
the
t is
relation between
1.
these three signals?
So step signal is U of t is 1. T greater than
U
or
of
equal
t
to
is
0.
t greater than or equal to 0 and
0 otherwise.
okay, good. What is the impulse signal? Yes, impulse signal del t. So please make this class more interactive. That will be better, I think. So impulse signal is del t
1.
1
T equal to
at
0.
t is equal to 0
0 otherwise.
and 0 at t not equal to 0 or otherwise. Okay. Now what is the relation between step signal and ramp signal?
So if you have a steps, the impulse continuing after t greater than 0, impulse keeps on
Mhm.
going, that will become a step.
Okay. So like if I say that this is the UT signal that will be going to from 0. Okay, so it becomes 0. Then here it will become and 1. So this is my UT signal. Now you know the differentiation. Yes, everyone knows the differentiation, I think.
Yes, sir.
Okay. So if I do the differentiation of this signal, what will we are getting? What the differentiation do? If I take the d of ut upon dt. So what is the meaning of this differentiation term? Can I represent this one as the u of t1 minus u of t2 upon t1 minus t2?
So,
Okay, this is a define the differentiation property. So if I see that from this region to this region, everywhere the signal is 0. That means this is 0, this is 0. If I am taking any time period difference, like for example, at this point, if I want to check what is the value, differentiation property. Okay, so from with respect to this one, if I take the previous and if I take the front, so everywhere the value is 0. So if this is the this time period is called the T1 time period and this called time period is called the T2 time period. What is the magnitude of signal at T1 T2? 0 minus 0 upon T1 minus T2, that becomes 0. Similarly, if we go to this point, now I consider this is the T1 time period, this is the T2 time period. Now u of T2 minus u of T1 upon T2 minus T1. Okay, u of t2 1, u of t1 is again 1. And what is the time period difference? That becomes t2 minus t1. So the value is again 0. That means if I differentiate the signal, so we are getting everywhere 0. We are getting everywhere 0. Only we are getting where changes is occur. And the changes is at this point. So it will be go to high and again it will be go to 0. And this signal is what?
Impulse signal.
Impulse signal. So can I say this thing that d by dt differentiation of ut signal is del t signal. Okay. Now similarly, one more signal is there, rt signal. So what is the equation of mathematical expression of the rt signal?
So equal to
T.
1 t greater than or equal to 0, 0 otherwise.
Okay, so the signal representation is like that. At t is equal to 1, the value is 1. At t is equal to 2, the value is 2. At t is equal to 3, the values. Okay. Now again, if I am taking the differentiation of this one, so del of rt upon dt. So can I put it r at t is equal to 1, or sorry, r as t is equal to 2 minus r at t is equal to 1 upon time period 2 minus 1. So what is the value of t is equal to 0? 2. The value is 2. What is the value of t is equal to 1? Value is 1. So 2 minus 1 upon 2 minus 1. It becomes 1. Okay. Now if I take a 2 or 3 points, that means at t is equal to 3 minus t is equal to 0. So if I take r of t is equal to 3 minus r of t is equal to 2 upon 3 minus 2. What is the value of rt minus t equal to 3? 3. And what is the value of r at t equal to 2? Becomes t is equal to, again it becomes 1. Similarly, if I take the consecutive points and take the differentiation, so everywhere the signal is 1 1 1 1 1 1 1. And this signal is what?
Step signal.
Step. So it's become ut. So I can just say that del upon del t of rt is equal to ut. Okay. So r rt signal, if I do the differentiation, it becomes ut signal. If I do the differentiation again, it becomes del t signal. Okay. Similarly, if I go to the reverse process, like if I do the integration of del t signal, it becomes ut signal. If I differentiation of, sorry, integration of UT signal, it becomes RT signal. Okay,
Yes, sir.
so these three signals are correlated to each other. Now with this, I think you also discuss the property of impulse signal. Yes, have you covered the property of impulse signal?
Yes, sir.
So if you remember one property, that integration of wait a minute. If I apply the time shifting property like del of t minus 2, so what is this signal? Yes,
So equal to 1, then t equal
1
to 2,
is equal to 2 and
0 when
0.
t not equal to 2.
Okay, so every time if I am talking about the impulse signal, so the signal value should be 1 when this term should be 0. Del of t minus 2 should be 0. If this value is not equal to 0, we can say the value will be particularly, like for example, if the value is at t is equal to 3, this value will be 0. So we are getting one value at t is equal to 3. Okay. So this is the first property of time shifting. The second property, time scaling. Now if del of t is equal to 1 at t is equal to 0 and 0 at t is not equal to 0, okay, so if I take the del of alpha t, okay, del of alpha t, so the value is 1 upon mode of alpha del of t. Okay, 1 upon mode of alpha del t. This is the second property. The third property, time reversal. Del t signal is a even signal. You know the even signals?
Yes, sir.
So we can say del of minus t is equal to del t. Okay, so for the time reversal signal, if I put the del of minus t, so it becomes a del t. Okay, so like for example, I just take del of
minus 4t plus 2. So the value of the alpha, sorry, the signal is 1 at t is equal to what? Yes, tell me. At what value of t the value should be 1?
Minus 4 plus t equal to 0, and then
Minus 4t plus 2 becomes 0. So minus 4t is equal to minus 2 and t is equal to
half.
minus 2 by minus 4, that is 1 by 2. So at t is equal to 1 by 2 the value is 1, otherwise the value is 0. Okay. The fourth is if I take a del of t minus t naught of xt signal. So the value of this signal is x of t naught del of t minus t naught. Why? The value of this signal will be 1 when t is equal to t naught. Okay. Otherwise the value is 0. Okay. And when 0 multiply with xt, that means becomes complete signal should be 0. So I say that the xt multiply with del of t minus t naught, the value is lies when t is equal to t naught, and the value is 0 when t is not equal to 0. So this consideration the value is always 0, but for this consideration the value will be exist at when t is equal to 0. So what I do, if I put the value of t is equal to t naught, so it becomes the x of t naught del of t minus t naught. So this is the fourth property of impulse signal. Similarly, if you are talking about the fifth property, so minus infinite to infinite del of t minus t naught into x of t. We have already seen what is the value of this one. Minus infinite to infinite x of t naught into del of t minus t naught dt. Okay. Now here t is not exist. Only t naught is exist and t naught is a constant value. So this particularly value will be constant. So can I take it common?
Yes.
So x t naught integration minus infinite to infinite del of t minus t naught dt. And the area under the curve of impulse signal is
It should be 0.
the area of the impulse signal is always equal to 1.
1. Yes. Okay.
So x of t naught multiplied by 1 becomes x of t. So these are the some properties of the impulse signals. Okay. If we say like for example, I just say that x of t is equal to del t. That is represented by the this definition. 1 at t is equal to 0 and 0 at is equal to infinite. Sorry, t is not equal to 0. But this particularly definition, mathematical definition is only used for a graphical representation. But practically, if we say what is the impulse signal, so The impulse signal is the signal whose area under the curve from minus infinite to infinite should be equal to 1. Okay.
Okay.
Now, again, if I am talking about the what is the basically impulse signal is practically exist or not. Okay. So we say that the practically impulse signal is not exist. Okay. I am taking one example that this is my signal. My current flow from the through the wire is 0. Okay, and when it is going to the this point, I what I do, I just on my basically switch on my plug, so current will be higher, and again I just do the वापस switch close, so my current should be lower. Like this is my circuit. Okay, when I close the switch, so my current will be start flowing because circuit is completing, and when I open the circuit, the current is again a 0. So when I initially my switch is off, no current. After that, my switch is on and current will be start flowing. Okay, and after that, certain after a time period, I just again close the switch. But what impulse says that the time taken from off to on, then on to off, it becomes 0. It becomes 0. Okay, but practically it is not possible. Why? Because when you switch off and on, it may be taken some time. Either maybe this time is in millisecond, this time is in microsecond, or this time is in nanosecond. But it always take time from off to on, then on to off. Okay, so practically the impulse signal should be lies in this way. Okay, and this is the pulse duration delta. The value of delta is approximately 0, but practically it is not equal to 0. Approximately equal to 0, but not exactly 0. Okay,
Okay.
so how I check what is the magnitude of this one? So in this scenario, I use this definition that uh, the area under the curve of the impulse signal should be 1. Now, if it is a rectangle pulse, if this is a rectangle signal. So what is the area under the curve?
Yes.
Height.
Height times
If I'm
the
taking height,
length.
height multiplied by the length should be always equal to 1. So the value of x is nothing but 1 upon delta. Okay,
Okay.
and if the this particularly width is reducing, if delta is reducing, x is increasing, or 1 upon delta is increasing. Like if I'm going to reduce, basically I'm reducing. So when I reduce this one, so basically height will be increases. Why? Because the area under the curve is constant, and that is this is the main property of impulsive. Okay,
Okay, sir.
now anyone have any doubts, so they can ask. Yes, any doubts? No doubts? Yes, no doubts?
No doubts.
Okay. So, if you don't have any doubts, so we
Sir,
will. Yes.
sir, in one of the lectures, it was said that the inductor circuit follows ramp signal. So, can you
The
explain me that?
inductor.
How does yes, current in inductor circuit follows ramp.
Mhm. Basically, it is increasing now. That's why it is called the ramp signal.
Sir, why is it increasing like if the voltage is constant?
The voltage is constant, but like for example, if we are talking about the capacitor, or if we are talking about the battery, okay, battery basically store the voltage, and inductor will be store the current. Okay, when you are going to plug in the voltage, the battery in a some power supply. Now, what will be happen is the battery when you plug in the battery is sharply charged up to 100%, or it will be increasing.
Increasing.
So similarly way, the voltage that we provide is the constant voltage, but battery initially 10% charge, then 15% charge, then 20% charge. So basically, it is increasing. Okay, so that's why similar way the current in the inductor is also increasing when we apply the supply signal. So the current, because it may take the time to turn on, basically for the mutual inductance. Okay, because if you know the concept of the inductor, so inductor follows the property of magnetic field, not of the electric field. Okay, and everything will take time, so that's why it will be increasing when you apply the voltage for a time period. What is the value of inductance? What is the voltage with respect to the inductance? Yeah, what is the voltage?
Di by dt times L.
Yeah, V is equal to L times di by dt. V is equal to L times di by dt. If current is not increasing with respect to time, so this particular effect is
Sir,
decreasing.
are you writing something?
Not exactly, I just say wait a minute.
Okay, okay, sir. Sir, please say it.
Okay. So now, so if we say that the voltage and across the inductor, so V is equal to L di by dt. Okay, and if the current is constant with respect to time, so this particular factor is zero. If this one is zero, so the voltage will become zero. Okay, so that's why we are taking that inductor is a basically is ramp signal, because we have take the integration of this one, and due to the integration differential integration, basically differentiation of the inductor ramp signal will be the step signal. Okay, so the integration of the ramp signal will be a step signal, and what
Sir,
voltage
I
with
didn't
this.
get this point that
Okay,
integration of.
now it's clear.
Sir, I didn't get this point that the integration of ramp is step signal.
The integration of ramp is a step signal we already discussed. No? Like we are talking about the three different signals: ramp signal, step signal, and the impulse signal. So the relation between these three signals is that if I differentiate the ramp signal, so it becomes the impulse signal, step signal, and if I differentiate, it will be the impulse signal. Similarly, The integration of the impulse signal is the step signal, and integration of step signal becomes the ramp signal. Okay, and like if I will explain it again. So mm, now what is my ramp signal? Like this one. Yes, that's fine. Now if I say t is equal to 1, the value is 1. The t is equal to 2, the value is 2. The t is equal to 3, the value is 3. Okay. Now if I take the differentiation d of rt signal upon dt, that is the value is equal to r at t 1 minus r at t0 upon t1 minus t0. Now if this is the t1 and this is t0. This is t0. So t1, the value of rt signal at t1. What is the value? 1. And value of rt signal at 0 is 0 upon 1 minus 0. That becomes 1. Again, if I take the r of t2 minus r of t1 upon t2 minus t1. So this point is t1 and this point is t2 if I'm taking. So what is the value? 2 minus 1 upon 2 minus 1. Again, it becomes 1. If I'm taking r of t3 minus r of t2 upon t3 minus t2. So this is for this point is t3 point. Okay, so what is the value? 3 minus 2 upon 3 minus 2, that is also 1. So basically when I integrate differentiate the ramp signal, so it behave as a impulse signal. Okay.
Yes, sir.
Okay. Now if I say the voltage V is equal to L di by dt. Okay. And if my voltage is basically a step signal. If my voltage is a step signal. Okay. So the value of voltage is nothing but L di by dt. So this voltage is dependent on the differentiation of the I signal. Okay, so I say that voltage is dependent on the di by dt. So it is differentiation of the I signal. Now, if I is step signal, so the voltage is which type of signal is this? I is the step signal. The differentiation of the step signal is impulse signal. So voltage is basically a impulse signal. Okay, and if I is ramp signal, voltage is a step signal. So if my voltage is step signal, it is a condition that current is a impulse signal, ramp signal. Sir.
Yes, sir.
Okay.
Yes, sir.
Any other doubts? Any other doubts?
No doubts.
So if no doubts, so kindly we stop here.
Yes, sir.
Okay.
Sir, I haven't been added in Discourse group yet.
Yes, sir.
Yeah,
So,
what you are saying?
Sir, I haven't been added in Discourse group yet.
Mm, okay, you have added me.
no, sir. We are not added to the discourse. Our email is not added to the discourse.
Okay, actually my discourse. Okay, let me check. Otherwise, if you have any doubt, you can directly mail me. I think you have my mail ID. None of us have been added to discourse. That means you are also not in discourse. Student, have you added in discourse or not?
No, sir, we haven't been added.
Okay, so I think the discourse is not created yet for the yes. Hopefully, it will be created in 1 or 2 days. After that, I will add you. Okay, and if you have any doubt, you can directly mail me on this mail ID if you have any
Same mail
doubts.
ID.
I just put my mail ID on it. Okay. And I think you have this ID also. Mm, The ID is, or you can drop a message on this ID also. Okay, e2101@register.iit and .ac. Okay, so thank you. Let's stop here.
Thank you, sir.
Thank you, sir.